humanity. Our humanity.
So hello friends, today I am going to explain you Newton's forward interpolation formula. Not only this, I am going to explain Newton's backward interpolation formula also. So both two formula same type, and for same question you can apply. The only difference is Newton's forward interpolation formula is better or useful when we have to calculate the required value is near to starting value, and backward when it is near to end value. So I will explain here both the formulas. Suppose we have set of values x and y. X value is starting from x0, x1, x2 and up to xn given, and here y0, y1 up to yn values we know. Then Newton's forward formula, actually it calculates the polynomial y and x. What is the value? Y and x is y0 plus p del y0 plus p minus 1 upon factorial 2 del square y0 plus p minus 1 p minus 2 upon 3 factorial del cube y0 and so on. Where what is p? P is x minus x0 upon h. Here it is very important to know that Newton's forward interpolation formula we can use for equally spaced value, data set value. What is equally spaced? Equally spaced means common difference is same. Means whatever common difference of x1 minus x0 is there, same x2 minus x1 will be same. And what is the common difference? H. H is common difference, where h is what? Any xi minus xi minus 1. Where h is xi minus xi minus 1. N for any I. If it is equally spaced, then we can use Newton's forward interpolation formula. What is x0? X0 is initial value, x. If you want to calculate any particular value, then just put x value. Otherwise, answer will come in terms of x. Then whatever value you want to calculate, just put x value. So this is. Now I am going to explain one example. But before that, I will write Newton's backward. What is Newton's backward? It is again y and x, because already I explained in previous video when I am teaching about the difference table. For forward table, which value will play very important role? That is called last value, y and x, yn. So here in place of y0, we have to go for y0, p del that y0, yn plus p plus 1. In place of minus, it will come plus, and same del square yn plus p plus 1, p plus 2 upon 3 factorial del cube yn and so on. So this where p is again same, p is x minus xn by h this time. So just put values in the formula and easily you can calculate. Just you have to create first step difference table. If you are using forward difference formula, then forward difference table you create for given data set points. If backward we are going to use, then create backward difference table first. Then easily you can come to know del y0, del square y0, del cube y0 and so on. Similarly for backward, Once you create the table, you will come to know del yn, del square yn, and so on. So now I will explain one example. Example is very easy. Example is find the cubic polynomial which satisfies y01, y10, y2 minus 1, y3 10. Because 4 values given, so definitely it will be third degree polynomial. Now we have to, what we have to do, because date of set of values given, so x here, y here. What is x? X is 0, 1, 2, 3. What is corresponding y value? 1, 0, minus 1 and 10. Once you know y, what for forward difference table, first create del y. What is that? 0 minus 1, that is minus 1. Minus 1 minus 0, that is again minus 1. 10 minus 1, that is 11. Now create del square y. Minus 1 plus 1, that is 0, that is 12. Then del cube. What is del cube? 12 minus 0 is 12. Now last value, only one value is there, so therefore definitely we can't find. So it means over. We have to go up to del cube. Now we are going to use formula. Formula is this one, just we put the value. But before that we calculate what is p value. P value is x minus x naught by h. So what is x naught? X naught is 0. What is h? Difference of any two consecutive xi values. So 1 minus 0, 1. So what is x? P value x. So in place of p we have to put x. This is your y0. This is your del y0. This is your del square y0. And last one is your del cube y0. Just put this value in the given formula. You will calculate the y next value. So I will do here. Now I am going to put the values. So what is y and x? y0. y0 is 1. What is p? X del y0, that is minus 1, plus x minus 1 by factorial 2 del square y0, that is 0, plus x minus 1, x minus 2 by 3 factorial del cube, that is 12. So what is your y and x? Is 1 minus x, this is 0, 3 factorial means 6, that is means 2, plus 2 x minus 1, x minus 2, x square minus 3x plus 2. So finally is 1 minus x plus 2x cube minus 6x square plus 4x. So what is the answer? 2x cube minus 6x square plus 3x plus 1. This is your y and x. Now whatever value they ask, suppose they ask find y10, y13. What is y13? Just in place of x put 13 value and you will get the answer. Now if suppose they ask you to find y2.5. y2.5 means here. It is near to end point. So better we will go for backward difference table. When you create backward difference table, value will be same. Just notation only change. So and there what is yn? This one. What is del yn? This one. Del square yn? This one. And del cube yn same. So this value will come in picture. And what is p value? X minus xn. What is xn? 3 by h. H is same. just whatever p will come and this value, just you put in formula and you will get the answer. So Newton's forward and backward, very important. So please take care of this. Hope you all understand. This is the easiest one. And next video we will go for central difference, and better we will go for unequal space. I think that is better. The Lagrange interpolation, that is very important. So I hope you all understand this one. Again, thank you, and please share and subscribe this one. Thank you.